All right, so let's see. Let's start the session. Um, Thank you for joining, all of you. Hopefully, all of you or most of you were in the session yesterday as well. We had a good 1 hour session yesterday on the same topic, but the first part of it. And today, our plan is to cover the second part of it and then uh, introduce you to the detailed boot camp that we are planning regarding 62443. So, for those of you who were not here yesterday, very quick introduction of myself. My name is Mubarik Mustafa, and I'm an industry veteran of 30 plus years um, with significant experience in industrial automation, control systems, as well as cybersecurity. And I have a few credentials to go by with my experience. Yesterday, we talked about um, the first part of the discussion was more on introduction to OT cybersecurity and how it is different from IT security. We spent a little bit of time on understanding what OT security is. And then we started talking about the IEC, ISA IEC 62443 standards. Um, we discussed that this is an international standard which covers all aspects of OT cybersecurity, and it is specific to OT cybersecurity. Um, I'll start with this slide today, which is like a continuation of yesterday's discussion. Uh, Apologies to folks who were not part of the discussion yesterday. I'll try and still keep it high level, so you at least get an idea about what we're talking about. I don't want you to feel lost. So it'll be a little bit of a connection with yesterday and continuation of the discussion. So to quick recap, yesterday we discussed that 62443 ISA IEC 62443 is not one standard, it's a series of standards. It has 4 sections in which multiple documents are divided. The first section, general, is referred to as with the numbering 1 dash. So you would have 1-1, 1-2, 1-3, 1-4. Second section starts with 2 dash and then 3 dash and 4 dash. And then within each section, each domain, you have different documents, 1-1, 1-2, 1-3, 1-4, and so on and so forth. And then just bear with me for 1 minute, please. I need to make sure that I can, my drawing is visible to everybody. So give me 1 minute, please. All right, so similar to the 1 dash, you have the 2 dash series, 2-1, 2, 3, 4, 5. We also discussed yesterday that some of these documents are international standards and some are technical reports, TRs, and some are technical specification. This is how ISA divides the different documents. So I've tried to put that in context in terms of the numbering. So anything you see in red, these are international standards, part of the 62443. The blue ones are technical reports, and the green one is TS. We also discussed yesterday that even though you have some extra boxes over here without a date, these dates on the top, these are the years in which the standards was released. So you can see 1-1 came out in 2007, 2-4 came out in 2018. 2-1, originally the first version came out in 2009, and then in 2024, the new version came out. But there are some other documents that are still not released yet. So ISA has planned these. Maybe some of these are under development and maybe released in near future. So with that recap from yesterday, what we'll do today is slightly dig a little bit deeper into these documents. Not too much, because we still have less than an hour to cover all this, but just to give you a little bit more glimpse into what is in each of these standards. Those of you who have seen the standards themselves may see these slides as familiar, but if you haven't, it'll just give you a glimpse into what are the contents of each of these standards. So if I just look at the first one, 1-1, concepts and models. As discussed yesterday, it focuses on terminology. It introduces the concepts and models used throughout the series. And 62443 is quite comprehensive, so it has a lot of different terminologies and concepts that they use. 1-1 is just a TS, a technical specification, which introduces you to these concepts and models. Of course, the rest of the documents have not been released yet. So what is inside 1-1? We'll just throw a couple of things on the screen. I'm sure that some of you may have heard about the so-called Purdue model. In fact, anybody who works in control systems or who has anything to do with OT security, at some point in time, this discussion about Purdue model or the levels 0, 1, 2, 3, 4, it comes into the discussion. 1-1, ISA 62443-1-1 is where these models are defined in the context of OT cybersecurity. So it talks about, for instance, if you're talking about a typical plant environment, you would have the actual process, the equipment that the control system is trying to control in level 0. Level 1 would have the controllers, the PLCs, and the safety systems, and the DCS controllers. Level 2 would consist of supervisory control, the HMIs, operator workstations. Level 3 is where typically the operations management components reside. Sometimes for example, the historian. It could be the application servers and maybe the Active Directory server, those kind of things. And this is where ISA likes to draw the boundary between IT and OT. Level 4 is considered to be the IT side of the world, the business side of the world. Similarly, if it's a SCADA environment, it will have something very similar. Level 0 would have the equipment. Level 1 would have the PLCs. Level 2 would have the local monitoring, and then you could have a wide area network connecting multiple sites into a centralized control center, which would be, I guess, classified as level 3 with supervisory control and systems management. But once again, there'll be a boundary between IT and OT, and level 4 will be considered as IT layer. Something that is very important to understand in the context of this Purdue model or the ISA reference model is that the reference model itself is not a cybersecurity model. A lot of folks think that, I have heard some of the clients say that, well, we need to implement the reference model, the ISA 99 reference model to achieve cybersecurity. That is not a correct statement, because the ISA 99 reference model, it has nothing to do with cybersecurity. It just helps you visualize the different aspects, different components of the control system in terms of where they reside in the overall control system environment. It just gives you the context of, let's say, if I'm talking about historian, you would quickly think that historian most likely resides at level 3 and interfaces with IT. It gets the data from the supervisory control part and sends it to IT. So it just gives you the context. It doesn't matter from the cybersecurity perspective. This reference model or the levels, they have no direct correlation with cybersecurity. Indirect, yes, but direct, there is no correlation with cybersecurity. So this is one of the things that is part of the ISA 62443-1-1. It helps you understand these models, so you can then on top of it you can build your cybersecurity controls. Something else that is fairly commonly used within the well, an important concept that is defined in 62443-1-1 is this concept of zones and conduits. And I'm just giving you a glimpse of the document itself. Of course, the detailed training we would go into more details. So the previous slide was about the ISA 99 reference model. This slide is a cybersecurity model. So what it's saying is that you should divide your overall environment, control system environment, into zones and conduits. So you can see that in this particular case, it's an example of a large industrial organization that has multiple plants, plant A, plant B, and plant C. Within each plant, in this example, you have a control zone. So plant A has its own control zone, plant B has its own control zone, and plant C has its own control zone. And then we have a plant A, you can call it supervisory zone or whatever, they're just calling it plant A zone, plant B zone, and plant C zone. And then on the top, you have the enterprise zone. So the blue colors, the green color, and the yellow, these are all different zones from cybersecurity perspective as defined by ISA 62443-1-1. Note that in the context, if I try to correlate this with the Purdue model or ISA 99 reference model, you would see that this is level 1. If I go back to the previous slide, you would remember that we said level 1 is where the control, the PLCs, for instance, the control components reside at level 1, or Purdue model defines them or identifies them as in level 1. So you can see that controllers are level 1, and then you have some maintenance server, data server, application servers at level 2. And then seems like this is, it could be, this seems like level 3, and this seems like level 4, enterprise. But you can see that both level 1 and level 2 for plant A, they reside in one security zone. So this is, once again, the purpose is to re-emphasize that level 1, 2, 3, 4 have no direct correlation with cybersecurity. Otherwise, ISA would ask you to put level 1 in a separate zone. All right, so let me draw again. ISA would say put level 1 in a separate zone and level 2 in a separate zone. But there is absolutely no requirement from that perspective. There is a 62443-1-1 defines the criteria through which you identify or you classify or segregate your facility into zones and conduits. So this is one more topic that is a very, I guess, important concept from 62443 perspective. The concept of zone and conduits is defined in 62443-1-1. We've talked about the zones. So these blue and the greens are the zones. Conduit, as defined by 62443-1-1, is something that connects two zones. Okay, it's a simple definition that anything that connects to zone is a conduit. So in this case, you can see that there's a conduit over here, there's a conduit over here, and there's a conduit over here, and then there's a conduit up on the top as well. So from cybersecurity perspective, the zoning and conduit is extremely important, and not just from 62443 learning perspective, but also from the concept of cybersecurity. Because when you talk about OT security, the very first thing that comes to mind, the very first thing that I recommend that needs to be done is zoning, segregation, because that is the first line of defense for you for instance, between IT and OT. If you don't have any kind of segregation between the two, then you're exposing your OT systems to the threats that are typically found on the IT side. You have an email server, maybe some laptops, user workstations on the IT side. And if the OT environment is not segregated from IT, then you would be exposing the OT environment to all those threats that may exist on the IT side. So segregating IT and OT, and potentially segregating within the OT environment, just like this example has done, that they have segregated each plant's control zone separately, and then the supervisory zone is separate, and then the enterprise zone is separate. So this concept of dividing your control system into zones, it's an extremely important concept that is at the heart of 62443 concepts. So very important to understand this, and all of this is covered in 62443-1-1. All right, so I'll leave it at that. This was just a glimpse of what kind of information is described, or the contents of 62443-1-1. Let's move on quickly to the next section, which has a lot more, I guess, details. Policies and procedures, I would call it more of a governance, not just the policies and procedure part, but it has 2-1 and 2-4 are the only two standards that are released yet. I would skip 2-4 for today, focus more on 2-1, because that is what it defines the security program requirements for the control system itself. If you remember, and maybe we can do a recap, that 62443-2-4 talks about security requirements for these service providers. It is not for the control systems owners and operators, not for the industrial facility owners and operators. It is for those companies, those organizations which provide services, control systems services to the asset owners. So obviously, from implementation perspective, the service providers also have to implement certain policies and procedures on their own system, but they're not implementing those on the control systems themselves, because service providers don't have control systems. It's the asset owners who have the control systems. So let's spend a little bit of time looking at 62443-2-1. What are the contents of this standard? Primarily, it describes what is required to define and implement an effective IACS cybersecurity management system. In my opinion, this is the single most important standard from ISA's perspective. Yes, the rest of them are also important, but 2-1 is at the core of it. If you have not implemented 2-1 properly, then any other security controls that you may have, the effectiveness of it cannot be guaranteed. 2-1 is the umbrella, the governance, the security program requirements are defined in 2-1. If you have an effective security program, the maturity of your security controls will definitely be much more robust compared with if you don't have the governance implemented at the top. So let's spend a couple of minutes, maybe 5 minutes or so, not a couple, on exactly what is in the new 62443-2-1. When I say new, if you remember from the previous slide, the original 62443-2-1 was released in 2009. If I am correct, yeah, I don't want to misstate it. So you can see over here that the original one was released in 2009, and the new version released in 2024. So what I am showing now on the screen is I'm going to refer to the new version, the 2024 version, not the old one. Obviously, because the old one is obsolete now. So what is security program requirements? So primarily, this document is focused towards asset owners. Why? Because they have to build their security program to protect themselves, to protect the OT environment from cyber threats. While it is primarily for asset owners, obviously service providers and GRC personnel and auditors, they also need to learn this standard. Because why? Maybe the asset owners would ask service providers to design and implement the security program for them. Maybe the governance GRC personnel, because every time we talk about security program, it is a governance requirements we are talking about. So GRC personnel within the organization, or consultants, or even auditors that need to audit the OT security of any organization, they would need to know what are the security program requirements so that they can do the audit itself. So not just the asset owners, service providers, anybody, in my opinion, who has anything to do with OT security will need to understand this standard very well. So what does it do? 62443.2-1, what does it talk about? It provides the asset owners with the framework to develop and evolve their security program. Cybersecurity is not a one-time thing. Okay, let's give the contract to someone who can come in and implement security and leave. That's not how it works. Cybersecurity is something dynamic. It needs to be designed and implemented, yes, but it needs to be maintained. And if you don't have an effective program on how you will maintain the maturity of your security, how you will cover the people, process, and technology aspect of cybersecurity, if you don't do that, then your security maturity will be questionable, in my opinion. It focuses on establishing the security program and defining and achieving the maturity levels. So this concept of maturity level is something that has been out there for quite some time. Those of you who are into studying the different models for cybersecurity, maybe you have heard of C2M2, which is a cybersecurity maturity model. It talks about maturity. The idea is that you have to measure your cybersecurity based on how mature your organization is, not just based on how many firewalls you have implemented and how many antivirus softwares you have, and IDS and SIEM and SOC. So ISA has adopted, with the 62443-2-1, adopted the same concept of maturity levels, which we define over here. This screen, you don't have to read all these details, but just understand the concept of maturity levels. Any organization could be in different stages of maturity for different security program requirements. Okay, if you perform the security functions or processes in an ad hoc manner, either undocumented or not fully documented, then you don't have consistent implementation over time. You cannot guarantee consistency of implementation of those processes over time. So if your organization is operating in that way, you are at initial level of maturity as defined by 62443-2-1. Managed is where the documents exist, but the execution, or if you can read this part, the documentation exists that describe how to manage and deliver the performance and capability, but it is not as well implemented. When these practices are in place, their execution is performed and managed according to the documented plans. But it's still not where you can guarantee that it's repeatable over time. At least you have documentation in place about what you want to do. If this is where you are in your organization, you are at the managed level. of maturity. At the next level of maturity, and you can see the word maturity will start making a little more sense, that you're becoming mature. The cybersecurity practices in your organization are becoming mature. You're doing ad hoc over here at the top. The cybersecurity is not mature. It is managed, which means that you have the documentation, but you don't have repeatable practice, or you don't follow those documentation consistently over time. In the third level, execution, at this level, performance can be shown to be repeatable over time within the industrial control systems. Okay, at the second level, managed level, you had the documentation and people were following it in general, but it was not consistent. It was not repeatable time and time again and again and again. And then the fourth level is improving and optimizing, where you have gotten to the point where even the procedural and change management processes, the improvement is also part of the overall concept. So I'll just give a simple example. I know this is becoming a little bit dry, but let me give a simple example of this, which I'm sure everybody can relate to. Antivirus updates, something that we all kind of, love and hate. Without the antivirus, we're doomed, but updating the antivirus or patches, for instance, in a control system environment is a nightmare. Let's say the patching, if you don't have your patching frequency defined or documented, if I go into a facility and ask the question that, do you have documented policy and process in place on how often you will do the patching and what will be the process that needs to be followed? If the answer is that, well, we do perform patching, but we don't have any documentation to define how it will be done, then the organization is at very basic level, initial level of maturity. For another organization, they may have the documentation in place that, okay, we will do patching every 3 months. And it is in place, meaning the people know about it, but they don't necessarily follow it repeatable, consistently, continuously. So sometimes they do the patching once every 3 months, sometimes they don't do, they sometimes miss. That means that the discipline is not in place to make it repeatable. Then they are in the managed level of maturity. Another company, another organization, if they claim that we have the documentation in place and we have communicated it, and we can prove that we consistently implement or follow it over time, it's repeatable, that yes, whatever we have written that we will do the patching once a year, and we do it once a year, guaranteed, no exception. Well, in this case, whatever they have their decision is, they have shown that they follow that process repeatable, consistently. So that organization is at a different level of maturity. So I'll leave it at that. The idea is that security program evolves over time. It goes through maturity level. So 62443-2-1, it defines the security program requirements, and it lets you assess where you are today in terms of the maturity. And then it lets you plan that, okay, we will, over the next 1 year, we will go from maturity level of initial to defined or managed or improving/optimizing. All these concepts are part of the 62443-2-1 standard. So what exactly do these maturity levels apply to? Now let's talk about that. So 62443-2-1 has divided the security program into what they call security program elements, SPEs. ISA is very big on abbreviations. SPE is security program elements. And what it is there are 8 SPEs. The first one is about organizational security measures. Second is about configuration management. Third one is about network and communication security, then component security, protection of data, user access control, event and incident management, and system integrity and availability. And within each of these, let me just go back here. Within each of these, it has element groups. So SPE1 has ORG 1, 2, 3, and it has its own definition that ORG1 is about security-related organizations and policies, security assessment and reviews, security of physical access, maybe something that will be a little bit more easier to understand. For instance, user access control, identification and authentication, authorization and access control, and so on and so forth. So it has divided the security program into SPEs, security program elements, and then within the elements, there are element groups. And then within the groups, you have the actual security requirements. So I'll show you a couple of these, not all, of course, in the interest of time. For instance, if I go to user 1, which I just showed you in the previous screen, I'll go back again, that for the user access control, identification and authentication, as well as authorization and access control. These are the two element groups, user 1 and user 2. These are the two element groups that we will discuss in the next slide. You can see in the user 1 element group, pardon me, in the user 1 element group, identification and authentication, these are the different elements that needs to be implemented. Okay, pardon me for the sequence a little bit out, but user 1.1 is user identity assignment, user identity removal, user identity persistence, access rights alignment. So these are the actual, you would call them requirements or clauses, whatever you want to call it. ISA calls it elements of security program that you have to implement. User login display information, login failure displays, session integrity, and then if you go to the authorization and access control, how the authorization needs to be done, separation of duties, multiple approvals, and all these things. So what we have done over the past maybe 10 minutes, took a little bit more time, is we have looked at what are the, at a high level, what are the contents of 62443-2-1. It, in a nutshell, defines the security program requirements that ISA recommends or requires, if you follow the standard, to be implemented with the on the industrial control systems. All right, moving on. Now we'll move to the third section and see it in a little bit more detail. This section has only two standards released to date, 62443-3-2 and 3-3. And this focuses on the concept of risk assessment for system design and the system security requirement, because focus of this group is on the system. So what do you need to do? How do you do risk assessment in case of system design? And how do you define the security requirements and the security levels for the different components of the industrial control system? Very briefly going into the details. This is part of the 62443-3-2. This is the process that ISA recommends that it must be followed to do the risk assessment for system design. I'll just quickly show a few things here. Maybe I'll zoom in so you can all see it better. That you start with identifying the system under consideration, this first part over here. And system under consideration is dividing your control system into smaller components, so it's easier for you to do the assessment. You look at the system architecture and diagrams. You update the system architecture so you know exactly what you're looking at. You perform initial cybersecurity risk assessment and document the initial evaluation of risk. And then you partition your system under consideration into zones and conduits. Remember, I mentioned zones and conduits in 62443-1-1, and the idea was that, well, ultimately it will apply somewhere. Well, guess what? In 62443-3-2, they're saying that you should partition your system into zone and conduits, and then you perform the risk assessment. If you see that the initial risk exceeds the tolerable risk, if the answer is yes, then you have to perform detailed risk assessment. And then if you still have residual risk, then you would define the target security levels for each zone. If you're done with it, you document the security requirements and submit it for asset owner approval. So again, don't be scared of the complexity. All I want to show over here is that 62443-2-3-2 defines the risk assessment process. So you're not going to understand this thing in 5 minutes if you have never done this before. But once we go through this in detail, you would understand how ISA recommends the risk assessment to be performed if you want to follow 62443-3-2. All right. Something else that ISA, now let's look at the 62443-3-3 system security requirements, and I'm just giving you a glimpse of the different components of these standards. When you're implementing system security, there's always this challenge of how much security to implement. If you have unlimited budget, let's say you have $100 million, your management has given you $100 million to implement all the possible security on your control system, you would still not be able to implement everything on every component. It is practically impossible. It's not just about the money. It's about some components don't have that feature available. In some cases, remember we talked about availability yesterday, that the foremost consideration in control systems is availability. You need to keep the plant running. You cannot shut it down because you want to implement cybersecurity. So even if you have the budget, it is not practical to implement every security control on every component of the control systems. But guess what? Nobody has unlimited budget, so that also comes into play. Limited budget and all the other constraints regarding what you can and cannot implement. So what should be done? How much security to be implemented? What security controls to be implemented? So ISA guides you from that perspective as well, that you define the security level requirements for each component. And this definition is fairly straightforward once you understand it. That security level 1 means that you want to protect your system against casual or coincidental violation. That the system itself is not very critical. You've done the risk assessment and you're saying it's not super critical, and we only want to protect it from casual attacker or coincidental violation, that we don't want somebody to accidentally do something bad over here, even if they don't have bad intention. We don't want accidentally something happening. For instance, maybe the power button. Let's say you have a operator workstation and the power button is somewhere very visible in the front. In most cases on the desktop computers, it is in the front, and you don't want that somebody accidentally presses the button. I'm giving you a very crude example. You don't want somebody to accidentally press the button and turn off the computer. Or you don't want that a casual attacker, even with maybe an insider threat with malicious intent, casually walks by and presses that button. What would you do? You would cover it. Put a cover on top that requires somebody to actively do something, maybe break the lock and then press the button. So if that's the level of protection you want, maybe you can just put a simple cover on top of the button. It's a very simplistic example, but it gives you the idea that you have to define the security level required for each component for each system to decide how much security to implement. If you want to protect your systems and components against intentional violation using simple means with low resources, generic skills, and low motivation, then you should define your security level target to be at 2. If I take the same example that for the power button, you just put maybe a cover that doesn't have any lock on it. Okay, so that means that if someone does want to intentionally violate, if you have put a cover, that means that nobody can unintentionally press the button. But if somebody wants to intentionally do something with simple means, all they have to do is just slide the cover away and press the button. It requires low resources on the part of the attacker. It requires generic skills. They don't have to be like a hacker guru for it to make it happen, and low motivation. They're just passing by. They just the boss yelled at the person and he's just upset. He said, well, let me just turn off the computer to teach him a lesson. It's low motivation. They are not motivated by I'm gonna get $1 million if I shut down this facility and all those things. Then that means that the protection you need to implement is at security level 2. If you want to protect your system against intentional violation, same as the previous one, let me clean it up a little bit. Same as the previous one, against intentional violation using sophisticated means with moderate resources, maybe ISCS or control system specific skills, and moderate motivation. It is just one level up, both in terms of the resources required to do the attack, the skills required to do the attack, and the motivation level to perform the attack. It's one level more than what was previously described. If this is the case, then you need to have a target security level of 3. And obviously, I'm sure you've guessed that the 4th one is one step further, that intentional violation using sophisticated means, just like the previous mean, but with extended resources and high motivation. Typically, to differentiate between these would be, I would call that this would be a typical hacker over here. And for instance, for example, this is a state-sponsored. I'm just giving an example. There could be other example as well. But if you want to protect against a hacker who really wants to do damage to your control system, and you don't care about state-sponsored attack, you should define your security level at 3. But if you think that you have a critical infrastructure which you want to protect from even, for instance, state-sponsored attacks as well, because states typically have extended resources and they have high motivation if they want to cause damage for political reasons, geopolitics and all that, then you should define the security level at 4 for your control system, for the components. All right, so I'm sure it's getting a little bit, I guess it's been about 50 minutes, and the attention span, I'm sure that you're losing a little bit of patience with it. So I'll quickly move on. I'll skip this part. This is another level of detail where the 62443-3-3 defines 7 foundational requirements. They call it foundational requirements. It also covers the similar things as in the 2-1, but 2-1 focuses on the governance part of it. 3-3 focuses on the system security. So what controls you should have Active Directory or multi-factor authentication, what kind of how do you restrict data flow, how do you respond to events in a timely manner, and these are all related to systems themselves, not for the security program or the governance. It is talking about what feature is available in a particular PLC and how you can enable that feature and how much of protection you need from security levels perspective, security level 1, 2, 3, 4, and those kind of things. So 3-3 focuses on system security. I'll skip 4- part because this applies primarily to the product suppliers, and usually they already have experts available. For an average OT security person, you don't need to get into 4-1 unless you're selecting products. Then you should understand which products are certified by 4-1 or ISA. But if you're just implementing cybersecurity in an organization, 4-1 is probably relatively less important for you to understand. Focus needs to be on 2-1 and 3-3 and 3-2. I'll quickly jump into a couple of things regarding, maybe I'll skip this slide as well in the interest of time. Just a couple of thoughts that we all know. I mentioned it earlier as well. Cybersecurity is not a one-time project. You don't do it one time and then say we're done. It's a continuous process where you need to design the system, the securities. You need to operate the security mechanisms as well. You need to maintain it. And security must follow the system for entire life cycle. What does that mean? That means that different roles within the organization need to, or with different roles related to cybersecurity, need to play their part to make it all happen. So, for instance, asset owners, they have to perform their function. System integrators have to play their role. Product suppliers have to play their role. And maintenance service providers have to play their roles as well. And most likely, every one of you falls in one of these boxes. Okay, if you want to get into OT security, then you should be, or you probably are, or you want, or you plan to get into maybe an asset owner, or you want to get hired by a system integrator or product supplier. So I think that's the part where I want to get to next, that why you should learn about 62443 and how we can help you. I'll pause with all the technical difficult discussion and come back to this key takeaway. We had this slide up yesterday as well, and this is the I guess the gist of it, that ISA 62443 is the leading standard regarding OT cybersecurity. It is a must that people who are part of different groups, relevant groups, they should learn about 62443. Including asset owners, because they are primarily responsible for OT security of their assets. Service providers should learn about it, product suppliers for sure, and IT personnel working in industrial organizations should also learn about 62443. These standards are quite comprehensive and quite complex, so significant effort is required to learn and understand. Hopefully, some of you have already access to these standards through ISA, but my message to you is invest in yourself, or get your company to invest in your expertise, because without that, you're not going to be able to implement a robust security program in your organization. We talked about yesterday about these certifications that are available from ISA themselves. So there are 4 trainings that you need to attend from ISA, and then if you take the exam, you will have each one of these, or whichever one you prefer to take the exam. You can take the exam and get the certification, and if you pass all 4, ISA gives you a badge for you're the cybersecurity expert from 62443 perspective. How can we help? And I'll wrap it up in the next 5 minutes or so. We have come up with a program called Blueprint to a boot camp called Blueprint to Compliance, ISA 62443 Technical Boot Camp. The first session will be on April 11th, 18th, and 25th. So it's 16 hours of total engagement over 3 weekends. These are weekend dates. Timing will be from 5 p.m. to midnight UAE time, including 1 hour break for the 6-hour session, because of course, if you hear me talk for 6 hours, you'll probably be dead by the end. We'll try and make it easy for you. But this is something that is, in our opinion, a must for folks who want to get into OT security. Bear in mind, this is not the official ISA course, so you're not gonna attend this course and then take the ISA exam. But what this course will teach you, it's a boot camp, it will teach you basically the practical, first of all, detailed review of the 62443 standards, but more importantly, practical approach to implementing 62443 to achieve your cybersecurity maturity. Because at the end of the day, you're not learning these standards just for the sake of it. If you are involved, if you are the asset owner, or you're part of a service provider organization or maintenance service provider organization, you need to implement 62443 to achieve the goals, whatever the goals are for the asset owners. So this boot camp will not only provide you a detailed understanding of 62443 standards, and it will help you pass the exam. If you take ISA course and you take the exam, if you have done our boot camp, definitely it'll help you pass the exam as well, because we will go into a lot of details about the standard itself. But more importantly, it's not going to be just a theoretical course where you take the course, pass the exam, and then forget about it. It'll help you understand the practical approach of implementing 62443 standards to secure the organizations which you work with. I have this slide over here. I'm not going to go through this whole thing again because I need to stop in the next maybe 5 minutes or so and have some question answers. But this is a glimpse of what we will talk about in the boot camp practically, because the 62443 standards, they are not grouped in a sequence in a way that, okay, you first implement 1-1, then 2-1, then 3-1. It doesn't work like that. Each standard itself talks about, addresses a different aspect of OT security. But we take this approach of the life cycle. For instance, how do you take your OT security from either specification or assessment part? You go into design, implementation, verification and validation, and then operation, and then maintenance, and maybe even decommissioning. If you're decommissioning or disposing of a control system or any component, what process needs to be followed? This sort of slide talks about which role it is relevant with. AO means asset owner, PS is product supplier, SI is system integrator, and SM is maintenance service provider. So for instance, in the design phase, you will be, asset owner will be accountable. The product supplier is a contributor, but the system integrator is responsible for the design. And it will talk about all these things that we mentioned about zones and conduits and the security measures and designing the security program and all these things. What is important to note over here is that this will be a very practical way of how you take it through the complete life cycle of your cybersecurity, starting with the assessment and the design and implementation and all those things. It also refers, on the bottom you can see which of the 62443 standards is applicable for each of the life cycle phases. You can see 2-1, 2-4, 3-2, 3-3 here. In the implementation part, 2-1 and 3-3 is important. Why not 3-2? Because 3-2 is about risk assessment. And if you have done the risk assessment during design phase, you don't need to do the risk assessment again in the implementation phase. In the implementation, you just need to implement the security program and the system security. So the standards will be used in each of these life cycle phases, and will guide you and teach you through how to how you can use the 62443 standards to practically implement security in your organization. So I'll leave it at that, and I'll open the forum for any questions that you may have. So what I will do is all right. Lots and lots of questions already. We had many questions yesterday. If your question wasn't answered yesterday, feel free to type it here. Let me see. There are some questions about certificate. I'm sure Maimuna will be able to address that separately. All right, so one question is, what is the training dedicated to 4-2 and 4-1? Is there a document that expands on what actually is needed from each 4-1 process requirements? So very good question. Let me go back over here if you don't mind. We talked about, let's keep it here. So the question again, as I'll repeat it, that which training is dedicated to 4-1 and 4-2? None of these. Because 4-1 and 4-2, if you remember, they're focused on product suppliers. And those are a lot more detailed technical requirements for the product suppliers. And in general, ISA expects the product suppliers to understand those concepts on their own, maybe, I'm guessing, because, for example, this one is fundamental specialist. It covers pretty much it provides you introduction to all the standards. The risk assessment primarily is going to focus on 3-2. The design is going to focus on 2-1 and 3-3. The maintenance is going to focus on 2-1, maybe a little bit of 2-4. So 4-1, 4-2, there is no training that I know of that ISA offers. If you're part of product supplier organization, you will need to maybe connect with the organization management to help you understand those standards better. Would the bootcamp attendees also get PDF copies of ISA 62443 docs? No, because these are not free standards. You have to purchase from ISA, and while we'll teach you different aspects of 62443, we cannot give you PDF copy of the standard itself. We could, but then we're going to have to charge you, and then it's the same thing. What is the minimum level in Purdue model I can apply data firewalling on? There is no requirement. Like I said earlier, Purdue model has nothing to do with, I shouldn't say that. It doesn't have any direct correlation to cybersecurity, so you don't have to apply a firewall at all. But if you want to, you can apply it at any level. You can put a firewall in front of the PLC itself. So there's no restriction as to where the firewall can and cannot be installed. You can put 1,000 firewalls on every device if you need to. So there is no segregation required between L1 and L2. And I'm guessing you mean, again, from Purdue model perspective. The answer is there is no such requirement to have any kind of segregation between any levels, because the levels are not cybersecurity levels. You may have to have segregation between two L1 devices, for instance. You may need to segregate two controllers. In fact, it's very common to have segregation between, for instance, DCS controller and safety controllers, because they are in two different security zones. So when you define the zones, you may have two L1 devices in separate zone, and then you will need to put firewall in between, or have some other kind of segregation in between. What are the practical steps to establish OT vulnerability management program according to IEC 62443? Security program requirements are part of 2-1, 62443-2-1. It does address vulnerability management. I would say that let's leave this question for the detailed discussion in the bootcamp, or if you have access to the standard itself, you can go through it as well. Um, are the maturity levels the same for C2M2? ISA has defined, while the security levels are generally similar in nature, you saw that on the screen, but ISA has defined it in their own way. And if you're following 62443, then you should follow the maturity levels as defined in the 62443-2-1. And the same person has commented that C2M2 has MIL 0, which in ISA case start from MIL 1 or maturity level 1. And that's exactly my point, that while the concept is the same, if you're following implementing 62443, then follow what is defined by ISA. What is the SPE meaning again? Security program element. Is there a process to do risk assessment for components, not systems? Interesting question. Yes, you can follow the same process for components as well, because when ISA says in the process itself, it says system under consideration, SUC. You can have one component, one PLC as a system under consideration. System doesn't mean the whole DCS. You could have different parts of the DCS, for example, each as a separate system under consideration. There is no restriction as such. I'll just take a few more. How would you secure isolated industrial systems that are not connected to the OT network, given that system owners may use USB devices for data transfer or temporarily connect the system to ad hoc Wi-Fi? Excellent question. I'll repeat the question again so everybody can hear it. How would you secure isolated industrial systems that are not connected to the OT network, given that system owners may use USB devices for data transfer or temporarily connect the systems to ad hoc Wi-Fi or mobile hotspots for vendor support? Implement 2-1 and you wouldn't have any problem. So I'll take a few minutes, take the liberty to go back over here. And I'll just pour my heart out because I've been talking about this for many years now, and hopefully, people are paying attention now. Security is not about technology. Cybersecurity is not about implementing technology. It's about implementing security program. It's about implementing governance. So just because a system, a component, a laptop, for instance, is not connected to a network doesn't mean it doesn't fall in the governance framework. Of course it does. So for instance, you would have, as part of the security program that you have on the screen, that how to manage the isolated systems. You would have a process in place for instance, for USB, because you need to extract some data. That's a business need. You will define a process as part of this one. For instance, it may be in SPE5, protection of data. It may be in component security. Look at this one. So you would define the policy and the procedure of how to use USB for that isolated system. And then you would train your people, and then you would consistently implement it again and again and get to your maturity level 3, that you have defined the process of how the USB will be used for that isolated system. You have trained your personnel, and you have a process in place to ensure that people follow that process consistently in a repeatable manner again and again over time. That's the only way to ensure security, in my opinion. Even if it is connected system, whether the system is connected or not, you need to build a security program, which is all about governance, and then you train people and make them follow it consistently so you can improve your maturity of the organization. Who cares about the firewalls? I have seen firewalls and data diodes implemented in organizations, and still they are vulnerable because the processes are weak. People just come in and temporarily connect. I have seen in a power plant myself, they had disconnected the physical network cable, and they were saying, well, our system is isolated, period. It's impossible for anybody to get in. And I was like, okay, well, let me have a look at it. And guess what? We found that once a month, for 5 minutes, they bring in a portable Wi-Fi 3G adapter from the telecom provider, connected to a system, because they have to take the report for how much power was produced. They connected just for 5 minutes without any kind of controls, without any firewall, and they take the report and they say, okay, well, our system is secure. No, it's not. And how to prevent that? By implementing a security program and maturing it. That is the only way to achieve cybersecurity. Otherwise, you can talk all about the firewalls and data diodes and everything, and nothing's going to happen. All right, so I think that I'll leave it at that. I'll hand it over back to. There are a lot of other questions, very good, very important questions, but I think that some of those will be answered in the boot camp. I'll go back over here to show a glimpse of what we're talking about. It is the boot camp will be, these are the dates, and I'll hand it back to Maimuna and Rakesh to further explain about the boot camp and how people can register and all those things. Back to you, Maimuna.
Thank you, Mubarik. It was a very informational session for me. Now I would like to ask Rakesh to share the more information about a new upcoming bootcamp.
Thank you, Humana. And thank you, Mubarik, for this informative session. After seeing the questions from audience, I'm thinking to shorten my presentation, and I'll keep rest of the window for answering couple of more important questions. Let me start with my presentation. Let me know when you're able to see my screen.
Yeah.
Okay, great. So before talking about the upcoming session, the training, I would take a couple of minutes to show you the journey we have traveled till now. Our journey so far. We started with Industrial OT Cybersecurity Foundation Training 1, which was a 2 days training. Then hands-on training on lab shop. Then followed by Industrial Training 2. Then Training 3, which was it was Arabic version Training 1. And then we came up with Industrial Cybersecurity Training 3. And it was followed by a OT Cybersecurity Bootcamp. So these are the total training till now we have covered. Now, what people are saying about us. There are a lot of positive feedback from a global participant. I'll be showing it here, some glimpse from the LinkedIn. People are saying good, that this channel, this platform is helping people coming from OT backgrounds or IT or people like us. It is helpful from them. And with that, everyone has rated us 4.67. Thank you so much, everyone. Now coming to this particular training, which is Blueprint to Compliance ISA 62443 Technical Bootcamp, which will be taken by Mubarik Mustafa, 16 hours of training, technical oriented session, direct interactions with world-class trainer. There'll be certification of completion after this, and this is the last important part, is there will be live question and answer session.